Within your GCSE science exams, a certain number of marks are awarded for extended response questions worth 4 to 6 marks. In biology, these are usually just extended prose, and in chemistry it may involve analysis of data or a big quantitative chemistry question, but in physics these questions often involve having to use two different equations together. In this video we're going to look at examples of questions that use both the equation for gravitational potential energy and the equation for kinetic energy. In this video we'll briefly refresh how to calculate GPE and KE and then look at two styles of question that use both of these calculations. If you think about any object that isn't just lying on the ground, some work has been done in order to raise it to a certain height and overcome its weight. In other words, we've had to transfer some energy to it. We call this store of energy gravitational potential energy. There are three things that will influence the size of a gravitational potential energy store: how heavy the object is, or its mass, the height it's been lifted to, and the strength of the gravitational field. If we put these three components together, then we can make up the 9th physics equation that you need to memorise for the exams. Gravitational potential energy is mass multiplied by gravitational field strength multiplied by height. As with all of your GCSE physics equations, it's important that you use the standard international units for each component, otherwise the answer to any calculation you do won't be the right size. So gravitational potential energy is a type of energy and therefore it's measured in joules. Remember, it is important that it has a capital J. Mass is measured in kilograms, gravitational field strength is in newtons per kilogram, and height should be measured in metres. You should also know that the gravitational field strength on Earth is 9.8 newtons per kilogram. Let's briefly look at some examples where we can calculate the total amount of gravitational potential energy stored in an object. So in this worked example, we have a 60 kilogram boy on Earth where gravity is 9.8. And when he's jumping to a height of 2 metres above a trampoline. So we want to know how much gravitational potential energy is stored in him at the top of that bounce. As you can see from the equation, we're doing mass multiplied by gravitational field strength multiplied by height. So that's going to be 60 times 9.8 times 2, which gives me a final answer of 1,176 joules, or you could just write that capital J for short. Pause the video and make sure that you're comfortable completing these four calculations. So, starting with our fruit bat, she's still on Earth and she's flying at a height of 5 metres. So 1.1 times 9.8 times 5 gives us an answer of 53.9 joules. Then we move on to our aeroplane, and what we need to notice here is that it's flying at an altitude of 11 kilometres, but kilometres aren't the standard international unit for height, so we need to convert this to metres first by multiplying by 1,000. So when I multiply 80,000 by 9.8 by 11,000, I get an answer of 8,624,000,000 joules. Then we move on to our astronaut. Now he's not on Earth anymore, so we need to use the value of the gravitational field strength for the moon. And again, we haven't been given the standard international units for his height. He's only jumping 50 centimetres, and so that needs to be 0.5 metres instead. So if we multiply 80 by 1.62 by 0.5, we get a GPE of 64.8 joules. And then finally, this cricket ball on Jupiter, the ball has a mass of 150 grams, but again, that isn't the standard international unit. So we need to convert to kilograms by dividing by 1,000. And that gives us a final answer of 14.874 joules. Next comes kinetic energy. Moving objects store kinetic energy, and as we know, they will have more kinetic energy if they have a heavier mass or if they're moving faster, so if they have a greater velocity. Kinetic energy is the 8th of the equations that you need to memorise for the physics exam, and we find it by multiplying half by the mass of the object by the velocity squared. Again, kinetic energy is a type of energy, so we measure it in joules. Again, mass is in kilograms, and finally, velocity is in metres per second. So let's say that our 60 kilogram boy has got off the trampoline and he's now running at 5 metres a second. The total amount of kinetic energy that he has can be found by doing half multiplied by 60, his mass, multiplied by 5 squared. So 5 squared is 25, and if I solve this completely, I get 750 joules. Here's another opportunity to pause the video and make sure that you're comfortable calculating kinetic energy. So for question 1, we have our 900 kilogram car driving at 20 metres per second, so we do half times 900 times 20 squared. That can be simplified to 450 times 400, which gives me a final answer of 180,000 joules. If I go through the same process, my aeroplane has a lot of energy. For the basketball, you need to make sure that you've converted the mass into kilograms before you start. So we're going to have half times 0.625 times 2 squared, which gives the basketball just 1.25 joules of energy. And then my 350 kilogram horse has 34,300 joules of energy. Before we get to the maths involved in these questions, we just need to nail down 2 assumptions that we're going to be making. The first one is that, as you know, energy is conserved. So what this means is that you can't make any new energy and you can't get rid of energy that already exists. All you can do is transfer it from one form to another. So in these questions, we're going to be looking at kinetic energy turning into gravitational potential energy, or back the other way. The other assumption that we're going to make is that we have perfect transfer. So we're living in a world with no friction and with no inefficiency. The total amount of kinetic energy will become the total amount of gravitational potential energy, and vice versa. Let's have a look at some questions. In this first example, we're going to be given the data necessary to calculate kinetic energy. But rather than just stopping there, the exam board are going to ask us to calculate maximum height. These types of questions are often framed in terms of roller coasters or rockets. We're assuming here that the roller coaster is travelling along and then it reaches an upwards loop and it doesn't have an additional motor. So what we're interested in is how high can it get just from the kinetic energy that it already has. So in this example, our roller coaster has a mass of 700 kilograms and a velocity of 14 meters per second. And we're assuming that we've got this perfect, completely efficient transfer. So there's no friction, there's no loss of energy anywhere. So my first step is to calculate kinetic energy, because that's what I've been given the numbers to do. I have a mass, I have a velocity. My second step is to tell the examiner that the amount of kinetic energy is the maximum amount of gravitational potential energy there can be. I can't just suddenly get some more energy from somewhere. Then I need to rearrange my equation for gravitational potential energy to make height the subject. And when I solve that, I will get my final answer. So let's go through this process. The calculation for kinetic energy is half mv squared. So that's half times 700 times 14 squared, which gives me a total kinetic energy of 68,600 joules. That's my first step done. My second step is to explicitly tell the examiner I know that if that's the amount of kinetic energy, then that's also the total amount of gravitational potential energy it's possible for the roller coaster to get if it has this perfect transfer from one store to another. So my maximum amount of potential energy is also 68,600 joules. Now I need to use the equation for gravitational potential energy, and I need to rearrange that to make h the subject. So right now h is multiplied by mass and gravitational field strength. To get rid of them, I need to divide, and if I'm dividing on the right hand side, I also need to divide on the left. So I'm left with an answer of height is potential energy divided by mass multiplied by gravitational field strength. If I solve that, then I get an answer of 10 meters. Here's another opportunity to make sure that you're comfortable with this kind of question. So you can either pause the video at this point if you're feeling confident, or watch me go through one more quickly and then do the other 4 on your own. So for each one of these questions, we're always going to start by working out whatever it is that we can work out. So in this question, we've been given mass and velocity, and that means we can work out kinetic energy. So kinetic energy is half multiplied by the mass multiplied by the velocity, and that's going to give me 84.035 joules. And then if I rearrange the equation for GPE to make height the subject, then I can calculate that the height that it will reach will be 1.225 meters. So if we now go through the rest of these, the second question does have a little trick in it, in that the mass is not given in kilograms, it's given in grams. So hopefully you realised that and you were able to adjust before you did the calculation. So the kinetic energy for the yoga ball is going to be 1.53664 joules. And then again, if we say that the amount of kinetic energy is going to be the same as the amount of gravitational potential energy, and then rearrange the formula for GPE to make height the subject, then we get a height of 0.196 meters. My cyclist and their bike are going to have 3,601.5 joules of kinetic energy, so it's then the same amount of gravitational potential energy, and therefore the maximum height will be 2.5 meters, while the quad bike has just over 14,000 joules of energy and can reach a height of 4.9 meters, And finally, the rocket, if it takes off at 30 metres per second, will have 388,962 joules of kinetic energy. Maximum amount of gravitational potential energy will be the same amount, and if we rearrange and solve for height, we get a height of 44.1 metres. The alternative style of question is that we could be given the variables to calculate gravitational potential energy, and then rather than calculating GPE, we're asked to put it as equivalent to kinetic energy and then calculate the velocity. So we're back to our roller coaster, and this time it has a mass of 800 kilograms and a maximum height of 10 metres. So it's hanging there 10 metres up in the air, and then it goes over the top and starts to fall, and we want to know what's the maximum velocity that it can reach. So this time our first step is to calculate GPE, because we're always going to start by calculating whatever we can calculate. Then our second step is the same. We're putting GPE and KE as equivalent to one another. However much GPE an object has, the maximum amount of kinetic energy it can get, if this is a completely efficient transfer, is that amount of energy. And then we need to rearrange our equation for kinetic energy to solve it for velocity. And this is a little bit trickier because it does involve some square rooting and things. So we need to start out calculating GPE. That's mass times gravitational field strength times height. So 800 times 9.8, because that's the strength of gravity on Earth, times by 10 gives me 78,400 joules of gravitational potential energy. Therefore, the most kinetic energy that the roller coaster can have is that same amount. Kinetic energy is half mv squared. So to make v the subject of this, I'm going to double both sides, then divide both sides by m, and then square root. So that gives me a rearranged formula that looks a bit like this. So if I double that amount of kinetic energy, divide it by 800, and then square root my answer, I get a maximum velocity of 14 metres per second. So here are 5 more examples of the same kind of question. I'll go through the first one, but if you're feeling confident, you can pause the video now and do it on your own. So for this first question, we're going to start out and we're going to calculate the amount of GPE, because I've got mass and I've got height, and I know that gravitational field strength on Earth is 9.8. So 5 times 9.8 times 1.764 gives me that much gravitational potential energy. I know that the amount of kinetic energy is going to be the same, and then I solve the equation to make velocity the subject, and that gives me a maximum velocity of 5.88 metres per second. So pause the video and have a go at the last 4 questions. Once you've rearranged the equation for kinetic energy to make velocity the subject, there isn't anything too tricky about this. So again, our second question had that little trick in it where the mass is not given in kilograms, it's in grams, so you need to convert it. So gravitational potential energy is going to be 43.218 joules, and then by plugging those numbers into my rearranged kinetic energy formula, I get a velocity of 9.8 metres per second. My cat is going to have a maximum velocity of 7.84 metres a second, while the box, falling from a height of 240.1 centimetres, remember of course we need to convert that to metres, so it only has 58.8245 joules of gravitational potential energy, and therefore its maximum velocity is 6.86. And finally the chair has 864.36 joules of energy and is therefore able to reach a maximum velocity of 14.7 metres per second. I hope that you found walking through those calculations useful. Thank you very much for watching, and if you did find it useful, don't forget to like and subscribe for more GCSE physics videos coming soon.